All right, today we're talking about parallel and perpendicular lines. These two lines are parallel, but beyond that, what can you say about their slopes?
Same.
They're the same. What can you say about when these two intersect? Never. So if I said y equals 3x plus 7 and I said y equals 3x plus 6, do you get? Those will never intersect. So what if I asked for the solution to the system of equations? What would it be? Okay, so do you guys know what DNE means? Does not exist. Okay, and have you seen this sign before? It's basically short for the empty set. Okay, and no solution. SOLN is an abbreviation. Those are all good ways to say that. How about two lines that have the same slope and have the same y-intercept? Then they're exactly the same. Okay, good. So, I talked a little bit about this yesterday. Perpendicular lines, you'd take their slopes, and what do you do again? Negative reciprocal. So, reciprocal will be 1/3, and then I make it negative. And those two will be intersecting at right angles. Okay. What if the two lines are intersecting at right angles, and that spot is on the y-axis? I'd like you to write me a system of equations that will do that. I'm going to say it again. I want them to be intersecting at right angles, so therefore perpendicular. And I want their answer, the place where they intersect, to be on the y-axis. That's where they intersect, is right on the y-axis. You should be able to write a system of two equations that would do that. Y equals this and y equals that. It's not that bad. The slopes just, you have to know what to do with the slopes, which isn't that bad because they're just opposite reciprocals of each other. And then you just have to think about that y-intercept so that when they intersect, they'll touch each other. All right. How many of you have an answer? For some of you, this was too deep. I think you'll see it's not that bad. Sam, give me an answer.
Y equals 3x.
3x.
Negative 1/3x.
Negative 1/3 x. But you didn't have a y-intercept, or did you?
Plus 0.
So you could argue that it's plus 0, which means that they will intersect at the same spot, which is at the origin, which is also the y-axis. So you qualified. Good job. Yes?
You could also do the same thing, but plus 4.
Yeah, you could put any number here as long as they had the same y-intercept as each other. And you could have picked any numbers for these as long as they were opposite reciprocals of each other. All right, I'll give you another one. We're going to take the one I made, and I want you to make it perpendicular to that, but going through the point 1, 1. Now, I on purpose didn't pick the x-intercept, and I didn't pick the y-intercept. I picked another point to have them go through. How many of you knew I was talking about using this? Y minus y1 equals m times x minus x1. Raise your hand if you were already on that track. Okay, good. If you're not, start using that track, because now you know a point and you know the slope, and it's easy. I basically just did a complicated way of showing you the point and the slope. Here's the point. It wasn't even that complicated. And then the slope is that it has to be perpendicular to that. So you should have said y minus 1 equals slope of negative 1/3 x minus 1. Raise your hand if you had that one right. Okay, good. That's parallel and perpendicular lines. Is there anything more to it? Of course. Of course we can make it more complicated. But that's the basics. Yes?
The last question, you said they had to have the same y-intercept.
Wait. Back over here. Not that one. Let me find it. I think I may have erased it. Okay, so on the ones you have the same y-intercept, yes? You want to give me another example?
You said it was like perpendicular as long as they have the same y-intercept.
No. no. If, because I said that they had to hit at the y-axis, these numbers have to be the same. That was only because I said they had to touch at the y-axis. Okay, so to be perpendicular, they just need these two to be opposite reciprocals. So it was the other requirement I gave that on the other one, I said we have to have them touching at the y-axis. That's why these had to be the same. They don't normally have to be the same. Okay? All right, so back to this. Now I think we should go through the rest of the notes. Here we go. So if you're going to be parallel to 2/3, you'd be 2/3. If you're going to be perpendicular to 2/3, you'd be -3/2. Would you please finish the rest of these? There's a few weird ones in here. And if you have to, think about what the slope really means. Like, what the heck does it mean to have a slope of 0? There are lines that have a slope of 0. I know you're smart enough to go, well, this is just always the same. That's easy. Yep, that's that easy. But the other part's the more complicated part. Mr. K, front row, what do you get for the -3 turns into? 1/3. The -1 turns into? Good. Why not -1? Why aren't they just the same?
Because it needs to be a negative reciprocal.
All right. Yep, it's the whole opposite reciprocal thing. Okay. Keep going.
0, undefined, I don't know.
Yes.
It's okay.
It's vertical.
Because if you did 1 over that, then there's no way to answer that. Okay? But undefined's a good way to say it. And another way to say it is this would be a line with a slope of 0 looks like this. That has a slope of 0. So what's perpendicular to that? A slope that goes vertical would be a way to say it. Yep. And they are perpendicular, but there's no way to write that slope. Okay? And 0.75, I would change that to 3/4. And then I would be able to go -4/3. Does that make sense to you guys? Okay, good. What if you didn't have that trick of, oh, I can change it to 3/4 because it's like 0.73218 and you don't know the fraction for it? Then what do? Well, I could say that it's 1 over 0.73218 and then make it negative. And that would be okay, except you're not supposed to have decimals in your fractions. Do you guys know how to get the decimal out of a fraction like this? If I move this one 1, 2, 3, 4, 5 spots to the right, I got to add 1, 2, 3, 4, 5 spots to the right up there. And now I don't have a decimal in my fraction anymore. Who says you can't have decimals in fractions? The math police. There's another thing the math police don't allow besides decimals in fractions. You can't have square roots on the bottom. We're going to get into this more in second semester. But why? Because you can't divide by something that you don't know the ending of. Nobody knows the ending of the square root of 2. Now you can do what's called rationalize it, but you're not supposed to have a square root in the denominator. Yes?
So for these kinds of questions,
Yep.
do you want us to simplify it all the way down, or is it okay if we?
I'm just kind of riffing on this decimal thing. I'm just trying to say that if you are going to do 1 over a decimal, you're not allowed really to leave 1 over a decimal. I would get that you understand that you're not really supposed to have a decimal in there, but I'm just trying to show you, you just move it over. So do I want you to do that? Of course I want you to do that. That's why I showed you that.
Do you want us to also simplify?
Okay, and then, yes, obviously, ideal world would simplify, but I want to spend the next 20 minutes doing this one question. Okay, yes, simplify, always simplify, and never leave decimals in your fractions. All right, and this is another case of you're not allowed to have, the math police don't allow you to have square roots in the denominator. So just to clarify what you do on that, you'll need to see this more than once, but you multiply by square root of 2 over square root of 2. Who says I can do that? Well, it's 1. Multiplying by 1 is always legal. And then why is this any better? Because the square root of 2 times square root of 2 is the square root of 4, which is 2. And then there's a square root on top. Why is that any better? Because what you divide by isn't irrational. Okay, way. So that's called rationalizing a denominator. You don't really need to know that right now, so I need to move on. I'm just showing that for the super bright kids who are interested in that kind of stuff. Now, find the average slope. Okay, that's new. And it's important. Like, you have to know how to do this. What the heck are we supposed to do to find the average slope of that? Look at this. F of b minus f of a over b minus a. All right. So that's in the context of slopes and parallel lines and stuff. So you got to be able to learn how to find the average slope here. Now, just to clarify, you might be like, that's a point. What the heck? No, that's not a point. This is an interval. That's the interval where x is 1 to x is 2. So, would you agree that if I wanted to, I could take this and I could find 2 points on it? You could find 2 points on this? We could find 1,000,000 points on that line, but I just want 2 of them, and then I'll find the slope between those 2 points. These are the x values of the 2 points that I want. So I'm making an XY chart. Everybody please do this right underneath this, and put a 1 here and put a 2 here, and figure out when you put in 1 in the function, what do you get? The point 1 comma what? And then when you put in 2 in the function, what do you get? All right, so let's everybody put a 1 in, and did you already? You put a 1 in here, and did you get 1 to the 4th is just 1, times 3 is 3, plus 2 is 5. 1 comma 5, raise your hand if you had that one right. Good. And then if you stick in a 2, 2 to the 4th is 16 times 3. Yuck. Thank you. Plus 2 is? Now, if I had just said, what's the slope between 1 comma 5 and 2 comma 50? That would have been easy. And that's really what you have to do. So you just have to find these points first, and then it's just the slope between those 2 points? All right. Let's analyze that in the context of this. What is f of b? That's when they stuck b into the f equation and they got an answer. That's like the y value when they stuck in b. That's like what I just did here. That was, we figured out the y value when we stuck in x is 1. And then you have another point and you find the y value of that, and look at that. We're going to subtract the y values over subtract the x values. Isn't that pretty much slope? Do you get how these are y values? It's like f of x, right? So basically they're just saying, find 2 points, and then do the same old-fashioned slope formula where you subtract the y's over you subtract the x's. All right, so back to this. I now have the point 1 comma 5, and I have the point 2 comma 50, and if you can't find the slope of that, we got to move you back a class. 5 minus, what do you do again? Well, it depends. You can actually do it in either order, but I like to take the last number first. So I personally like to go 50 minus 5 over 2 minus 1. And that came up with 45 over 1, so my slope was 45. That's the average slope over that interval. Yeah, it's a very steep slope. Where might that have been? Let's look at a graph. Do you get how we might have a slope that would be super steep in that area? So what they're saying is, between this point and this point, what was the average slope? Well, when it's curving all over the place, how are you supposed to find the average slope? You know, like, do you really want to add up that slope? Wait, this slope that goes through, this point goes from there to there, and this slope, and this slope, and this slope, and I take from this point to this point, and that slope, and then all of the slopes in between there. You get what I mean? Like, there's a bajillion from here to here, that slope, all the points in between. You're finding the average slope of all of them. So it's actually kind of cool. Pretty easy, really. You just had to find 2 points and then find the slope between them. But what you're doing is pretty deep. You're finding the slope over a average of all of these slopes over a curve. Now, would this work on a regular old function? Yeah, it would. But let's just do one more to make sure you got that. Nope, this is a real word. We're going to skip over that. Those are good, but okay, I want to do one more before we do that time. So here's a function, y equals 2x plus 7. Would you tell me, what's the slope of that right now? Can you just tell me the slope? 2. We don't really need to use what I'm about to do to get that slope. But if I said, I want you to find the slope over the interval from 0 to 5, do you get that as not a point? This is an interval. Then all I'm really doing is saying make an XY chart and find out what you get when you stick in 0 and what you get when you stick in 5. Do you get any 2 points on a straight line? Should come out to a slope of 2. Like, because I know it's got a 2 right there. So I can tell ahead of time what this would be. I can tell the answer is going to be 2. But let's do it anyways. So stick in a 0 and you get 7. And you stick in a 5 and then you get 5 times 2 is 10 plus 7 is 17. And then if we go do the slope on it, it'll be 17 minus 7 over 5 minus 0. And that is 10 over 5, which is 2. Big surprise. So it works on straight lines, but do we really want to do this whole big process? No. If it was a straight line, I just know it was there. There's the slope, done. But if it was, all I have to do is change this to x to the 5th. And now it's a really weird looking curvy function. And I could find the slope over that interval. And it would be gross because I just put in a really big power and I got to do 5 to the 5th, which is insane. So I'm not going to do that. But that's the concept behind it. Yes? Louder, please.
On the question that we just did before we did this one, when we found the average slope.
Yep.
So when it's in line with like curves and stuff, if the problem can't just give you like any 2 points, right? It has to be 2 points on this interval.
They're going to give you an interval over which to find the average slope.
But they couldn't just give you any interval, right? They're giving you one that's really specific.
They could give you any interval
Any interval, and it would work. Why would it work with any constant?
because the slope will change based on what interval you pick.
So then how is it that average?
Now, we personally, because I was just giving you this example, we know this interval, because it's a straight line, the slope's always 2. So it doesn't matter what I picked for my interval. I could have picked anything for these 2 things. But let's just analyze a simpler curve. Let's see, today we talked about a parabola. Would you agree if I picked the slope between there and there, the slope will actually be flat? Okay. So let's do that. This is y equals x squared. I think this will help you understand it. So let's say it's y equals x squared. And let's say that I want to go between negative 2 and 2. Actually 1. Sorry, negative 1 and 1. So my interval would have been between negative 1 and 1. And then you'd go like this, and you'd put in negative 1, and you'd put in 1. And if I put in negative 1, I get 1. And if I put in 1, I get 1. And now I can take and find the slope between those, which is going to be 1 minus 1 is 0 over 1, 0 over anything is 0. It has a slope of 0. What's a slope of 0 mean? Well, it's a straight line. And think about if you took the slope like right there, and the slope 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 right there. Do you get that they would average out? Some of them were negative and some of them were positive, and it would average out to a slope of 0.
Oh, okay.
There we go. Okay, cool. All right, so that's what we're doing for that whole slope over a curve. You've never done that before. All right, so see if you really understand it. There's a typical test question, number 44. Figure out the slope over that interval. And I like that they're using brackets because it's more clear that that's not a point that they're giving you. I got 7/3. Anybody else got 7/3? Ruh-roh. I'm nervous. Maybe I screwed it up. I'm double checking myself. Oh, it's -1, -1. My bad. Okay, here we go. So then I have 8 minus -1, which makes 9. And then 2 minus -1. And double checking that too, because I didn't think about negatives when I put this in, because things to the third don't change their negativeness. Okay, so I think 9 divided by 3, I think it's 3 now. Raise your hand if you had 3. Good. A lot of you were smarter than the teacher on that one. Maybe it's more careful than the teacher in this particular case. Even though I know, when comparing IQs, many of you will beat me. But I happen to be more trained in math, so I can still handle being your teacher. But, all right, any other questions about how to do these where you have an interval? Feeling like you're getting this? Notice the first step was take these, put them here and here, and then you'll find the complementary y value, and now you have 2 points. And just like any 2 points, you can find a slope between them. All right, let's move on. This is just more complicated functions. I think you could handle it. Once again, I mourn for the people who still think that when you have the square root of 16 that you get 2 answers. You do not. There's only one square root of 16. The reason that people get that confused is because of solving this. And what they don't know is that when you square these, they think you get 2 answers for this, but you don't. It's just 12. And this is the absolute value of x. So that's why I keep saying this, that this comes out to an absolute value when you square root a variable. Okay, but when there's a problem where you didn't just introduce the square root, it has it in there in the first place, and I just stick a 16 in it, they're really just saying, what's the square root of 16? Which is just 4. Okay, and the other one was 0, so I'll just finish this one since I'm on it. If I put in 0, the square root of 0 is 0, so 0, 0. And if I put the 16 in, it's the square root of 16, which is 4, and then I would find the slope of that. 4 minus 0 is 4, over 16 minus 0 is 16, 4/16, which would be 1/4, would be my slope. All right. Same thing except context. So here's an equation, and they're saying that we only consider between 0 and 12. That's like for temperature compared to time, and the time is hours after 6 a.m. So if you're 0 hours after 6 a.m., that's 6 a.m. And then if you're up to 12 hours after 6 a.m., that's 6 p.m. And they're basically saying your temperature will follow this curve. Let's just think, do you agree it's a parabola because it's squared, and do you agree it's an upside down parabola? So do you think it's reasonable at 6 a.m. the temperature is low and then it goes up and then it comes back down again by 6 p.m.? That could happen. It would be weird if it went exactly in a parabola, but all right. And the way that they're going to be doing it would be only between 0 and 12, and so they only want part of it. But this is actually 6 a.m. right here, because it's hours after 6 a.m. is 0. So, okay, so it's basically dropping over most of the day. I feel like you could handle this. They would give you this interval between 4 and 8. You would again make an XY chart. You would stick in 4, you'd stick in 8, and then you'd figure out what you get when you stick it into the equation, and you'd put it right here and here. And once you got 2 points, You just find the slope. It's just got context so that at the end of the day, this isn't just numbers. It's like temperatures at certain times. All right. So, this is just super simple, actually. Here's a point, and they want it to be parallel to this. So didn't they just tell you, use the point 0, 0 and a slope of 3? That's all there is to it. Don't overthink this. Then on this page, it's the same thing, except it's the negative reciprocal one for perpendicular. Unfortunately, the word got split there, but perpendicular, okay? So this is the same thing. They gave me a point and they gave me a slope, but I don't actually use that slope. I use the opposite reciprocal of it. All right, and you should do those. And then here, this is pretty good, and it'll make you think. And there's an answer key, so you should try that one. It's not a stretch question. It's like you should be able to do that, and we could have questions like that on the test. And then challengers, again, these are always like particularly hard. Do it if you want a challenge. So it's not required. All right. Any other last questions? Otherwise, we have made it. Yep. The perpendicular aren't super hard. The parallel and perpendicular ones, we did practice that a little bit yesterday. A good point. So the main new thing for today is that whole slope over a curve. Okay. That's all I got for you for the video for today.